Okay, so today we are going to take a look at 11.4, multiplying and dividing rational expressions. Before we jump into the lesson though, I want to go back and kind of review some things that you probably learned back in either elementary, middle school, pre-algebra type thing. So let's take, for example, I have 3/7, and I want to multiply that by 14 over 9. Now, there are two ways that we can multiply this out, right? So we can either multiply the actual fractions together and then simplify, right? So you have 3 times 14. So if we have 3 times 14, we would have 42. And then 7 times 9, we have 63. And then we would say, oh, okay, well, that can simplify. 42 over 63 reduces to 2/3, right? There's an easier approach, which I would use, which is take a look at what you can kind of cross cancel. So the multiplication, because really this is 3 times 14 over 7 times 9, right? So anything in the numerator will cancel with anything in the denominator, right? Because really 3 goes into 9 3 times. So that would be, right, 3 over 9. And 7 goes into 14 2 times. So now you're left with 1 times 2, 2 in the numerator, 1 times 3, 3 in the denominator. Okay, so this leads us into our lesson, because if you take a look at this first example where we want to find the product, right, 64y squared over 5y times 5y over 8y. So you'll notice right away you have a 5y and a 5y. So because of the multiplication sign, we can actually just cross those out because that's a multiplication. And then what else can we cancel? Well, 8 goes into 64 8 times, and then y squared over y would just be y to the first. So notice everything in the denominator canceled, so that's going to just leave us with an 8y to the first, or just 8y. Now, if you don't like that approach, sure, could you multiply straight across? So for example, you would have 64 times 5, that would be 320, and then y squared times y to the first would be y to the third, over, in the denominator, 40, and then y to the first times y to the first would be y squared. And then if you take 320 divided by 40, you get 8. Y cubed over y squared is y. So you'll get the answer either way. It's up to you. I actually don't care which method you use, especially when you're working with these types where you have monomials, what we call. So when we look at the next example, all right, I am looking for either multiplying everything straight across and then simplifying, or looking to cross cancel things out. Now, because we have a lot going on in this one, I actually might try to just multiply the numerator out and then the denominator. So if I have 15 times 16, that's 240. Again, if you want to try the other method, that's fine. You can go ahead and try that. And then I have an s squared and s to the first, so that'll be s cubed in the numerator. I have a t to the third and a t squared, so that makes t to the fifth. In the denominator, I have 12 times 10, so that's 120. I have s to the first and s to the third, so that's s to the fourth. And then I have t to the first and t to the third, which is t to the fourth. Okay, now I want to simplify from here. So what can we cancel? Well, 120 actually goes into 240 2 times. Now, s to the third over s to the fourth, so if I subtract, I'd get, so I have a 2 here, I'd get s to the -1, so that means I'm going to put s to the first in the denominator. And then t to the fifth over t to the fourth is t to the first power in the numerator. Okay. So that's when we multiply. These are rational expressions with just monomials. Notice there's no plus or minus sign. So when we get to C, we'll notice that we have some binomials. So for example, n plus 4 is a binomial. Here, the other m plus 4 is a binomial. M plus 5 is a binomial. So right away what you might notice is you have an m plus 4 in the numerator here, and you have an m plus 4 in the denominator here. So we can actually cancel those out. Also, what else do we notice? Well, the 4 and the 3 we can't do anything with, but notice we have an m squared over an m. So m squared over m to the first will result in an m to the first in the numerator. So we're left with 4m to the first, and then in the denominator, what didn't we cancel? The 3 times the m plus 5. And just leave it like that. I don't need you to multiply it out. I actually prefer it with the parentheses. Okay, so when we take a look at D, we have to do a step first. So if we look at C, notice everything was in parentheses. We say it's in factored form. So for D, we want to try to factor this. So really the only thing that we can factor is the x squared minus 4. That's the difference of two squares. So I know I'm going to rewrite the numerator as x plus 2, x minus 2 over 2. Times, and then the second expression, 4 over x minus 2, we're just going to leave that. And then what do we notice? We can cross out the x minus 2 here and the x minus 2. And we notice 2 goes into 4 2 times. So what do we have left over? An x plus 2 times a 2. And we'll just put the coefficient out in front. Again, leave it like that. You do not need to multiply. All right, next one. E. Now, at this point, if you want to pause it and see if you can solve the, or, simplify the next one, maybe the next two on your own, go ahead and give that a try. Okay, n squared minus 16. So we're going to rewrite that. Again, that's the difference of two squares. N plus 4, n minus 4, over n plus 4. On the second expression, n plus 2, nothing we can do about that. I'm just going to put these in parentheses so we know that those are grouped. And then we have n squared minus 8n plus 16. This is actually a perfect square trinomial, but if you didn't recognize that, you can just factor it, and we think two numbers that multiply together to give us a positive 16 add up to negative 8, so that's a minus 4 and a minus 4. Okay, so let's take a look. What can we cancel? Well, in the first expression, the n plus 4's in the numerator and denominator will actually cancel. And then here, this n minus 4 will cancel one of the n minus 4's. So what do we have left out of the whole expression? We have an n plus 2 in the numerator and an n minus 4. And we can't reduce this any further. Okay, so n plus 2 over n minus 4, it's not like you can cancel the 2 and the 4. When it's attached to a plus or a minus sign, we cannot cancel. Let's take a look at F. So x minus 5, nothing we can do about that. And then let's take a look, x squared minus 7x plus 10. So how will that factor? Well, two numbers that multiply together to give us a positive 10 add up to negative 7, so that's going to be a minus 5 and a minus 2. Here, x squared plus x minus 6. So two numbers that multiply together to give us a negative 6 add up to 1, because 1x. So that's going to be a plus 3 and a minus 2. And then we have 5. Okay, let's take a look. What can we cancel? Well, I see x minus 5 and x minus 5 will cancel. And this x minus 2 and this x minus 2. So what does that leave us with? It leaves us with x plus 3 in the numerator. And it leaves us with a 5 in the denominator. Okay, so recall that when we divide fractions, you have to multiply by the reciprocal of the divisor. You might remember, in fact, my kids were just taught this I'm thinking like 4th or 5th grade, but you might remember the keep, change, flip. So we keep the 1/2, we change the division to a multiplication, and we flip the second one. And notice here the 2's would cancel, so we're left with 1/3. So we're going to use the same method, the keep, change, flip, to divide rational expressions. So if you see here 5x squared over 7. So notice that we kept the same. The division changes to a multiplication, and then we flipped the 10x cubed over 21 to 21 over 10x cubed. So from here, what could we do to simplify it? Again, you can either start cross-canceling now, or you can multiply everything out. So for example, 5 times 21, right? So I have 5 times 21 is 105. So I have 105x squared over 7 times 10 is 70 x cubed. So 105 and 70, well, 105 is divisible, and this is kind of hard to see because these are bigger numbers, but 105, if I divide it by 35, I get 3. If I divide 70 by 35, I get 2. And then x squared over x cubed, that would be 2 minus 3, so x to the negative 1. So we put x in the denominator, x to the first. Okay, find each quotient. So we are going to keep n plus 1 over n plus 3. We're going to change the division to a multiplication, and we're going to flip. So we're going to put n plus 4 over 2n plus 2. Now, this is where we want to take what we did on the previous page, because now we're basically changing it to a multiplication. So I have n plus 1 over n plus 3 times n plus 4. Now I notice 2n plus 2 has a GCF of 2, so I actually want to factor that. Okay, so we have that kind of added step. And then what can we cancel? The n plus 1s. What do we have left? N plus 4 over, I have 2 times n plus 3. Okay, again, put the coefficient out in front. Do not multiply in the last step. I prefer to leave it. Okay, B. We're going to keep 15y squared over 4x. We're going to change the division to a multiplication, and then we're going to flip. So 8x cubed is going to go in the numerator. 5y is going into the denominator. Let me see if I can cross cancel on this one instead of multiplying it out. I think that's a little easier. So I notice 4 goes into 8 2 times, and 5 goes into 15 3 times. So, and if it's easier for you to deal with the coefficients first and then multiply it all out, you may do that, or you could do it all at once. So in other words, notice I have a 3 and a 2 on the top, so I have a 6y squared x to the third over just xy. Again, you could have done this in one step or simplify it separate, but if I look at it this way, notice I'm going to have x and x cubed in the numerator, so 3 minus 1 is x squared, 2 minus 1 is y to the first, or just y, so 6x squared y. Okay, so let's take a look at the next one. First thing, we're going to keep 27c cubed d squared over 11d. Change the multiplication, or change division to multiplication. 9de over 2c to the third. Now, this has multiple terms, so actually I'm going to multiply these across. So I have 27 times 9, so that's 243. And then I have c to the third, d to the fifth, because I have d squared and d to the third, e, over 22. And then I have c to the third, d to the first. Now, 243, if you try to type this into your calculator, it does not simplify. Okay, they have no common factors. So what I'm going to do is I'm going to look at what can we simplify in terms of the variables. Well, I notice c to the third and c to the third, those are exactly the same, so that's going to cancel. So I have d to the fifth over d to the first, so that's going to be d to the fourth. And then I just have an e left, so I'll put e in the numerator. And that's the answer. Okay, take a look at d. So I have b plus 4 over 3b plus 2. times b plus 1 over 3b plus 12. Okay, now I look to see if I can factor anything. In this second one, I can factor out a 3. So I'm going to leave the b plus 4 over the 3b plus 2. And I'm going to leave b plus 1. And if I factor out 3, I'm going to be left with 3, or b plus 4. So I notice that b plus 4s are going to cancel. And what do we have left? Well, in the numerator we have b plus 1. In the denominator we have 3 times 3b plus 2. Again, I like to just put the number, right, the coefficient out in front. Again, do not multiply, leave it in parentheses. Okay, next one I'm going to write below here. So cb minus 12 over 3b plus 15 times b plus 5 over 12b plus 18. Now some of you might wonder, can I start factoring and changing from division to multiplication and flipping all at once? That's okay with me as long as you're clear about what step to do next. Okay, so 6b minus 12, I can factor out a 6, and I'm left with b minus 2 in parentheses. In the denominator, 3b plus 15, I can take out a 3, and I'm left with b plus 5. The numerator here, b plus 5, can't take anything out. But then 12b plus 18, so I think 12 and 18 have a GCF of 6. And when I factor that out, I get 2b plus 3. Now we look to see what can we cancel. Actually, I see 6's will cancel, and the b plus 5 and the b plus 5. And what are we left with? A b minus 2 in the numerator, and then 3 times 2b plus 3. Okay, last one on this page. So we're going to keep m squared plus 3m plus 2 over 4. Change division to multiplication, flip m plus 1 over m plus 2. Looks like we can try to factor the numerator here. So what two numbers will multiply together to give us a 2? Add up to 3, plus 2, plus 1. Okay, the second one, there's nothing we can do. Now let's see what we can cross cancel. I see m plus 2 and m plus 2. However, m plus 1 and m plus 1 are both in the numerator. So notice I have m plus 1 twice. So we're going to write m plus 1 squared over 4 and just leave it like that. Now, if you feel like you're comfortable and you can move on and start working on the homework, I am fine if you want to do that. Otherwise, I will work ahead, and there's these class practice problems. So for some of the lessons, if I think some students might want some extra practice, I'll walk you through class practice problems. Otherwise, you can finish the notes here on page 2 and start the homework. Let me take a look at the homework. So that homework assignment is number 24, and it's going to be on page 701, and it's going to be 11, 13, 15, 18, 20, 23, 25, 27, 31, 32, and 61. Okay, so if you're good here, you can start the homework. Otherwise, you can follow along for more practice. So find each product or quotient. So this one is already multiplication. So if you want to multiply straight across and then simplify, or simplify. So I think with this one, I'm going to just go ahead and start simplifying. So I see 7 goes into 49 7 times. And then I look at the 12 and the 14. So it looks like the GCF of those is 2. So if I divide 12 by 2, I get 6. 14 divided by 2 is 7. Oh, and take a look. Actually, this reduces again. 7 and 7 will both cancel. So that means, in terms of coefficients, I just have a 6 left in the denominator. Okay, I have an x squared and an x to the first. So I'll be left with an x to the first in the numerator. I have a y to the first and a y to the fourth. So 1 minus 4 is negative 3. Or, whoops, y to the third in the denominator. And then I have z to the first and z to the third, so 1 minus 3 is negative 2, or z squared in the denominator. Next one, this is also multiplication, but it looks like I have to do a little bit of factoring. So in the denominator of the first term, I have 4, and then b minus 3. Here, I'm going to factor this. I'm going to have b minus 3, b minus 1. And then here, I'm going to have, let's see, 30, 10 and 3, so it's going to be minus 10 and plus 3. Now I look to see what cancels. So b minus 3 and b minus 3, b plus 3 and b plus 3. What do I have left? B minus 1 and 4 times b minus 10. Number 3, so I have x minus 1. Now x squared minus 25 is going to be x plus 5, x minus 5. Times, okay, in the numerator, x squared plus 6x plus 5, that's going to factor into x plus 5 times x plus 1. And then in the denominator, I'm going to have x plus 2, x minus 1. Let's see what we're going to cancel. X minus 1, x minus 1, x plus 5, x plus 5. What are we left with? We have x plus 1 in the numerator. Now in the denominator, I have an x minus 5 and an x plus 2. Again, I'm going to just leave it like that. I'm not going to multiply those out. Now with number 4, it looks a little different. So I notice that the second expression doesn't have a denominator. So what we're going to do is we're going to treat that as a fraction over 1. So I have x squared over x plus 6 times, put that over 1. I'm going to factor this, so it's going to be x plus 6, x minus 3. So I'm going to be able to cancel the x plus 6's. And what do I have left? Well, I have x squared times x minus 3, and it's over 1, so I'm just going to leave it like that. Next one, I have 6x to the 4th over 5. Now notice this is division, so I'm going to change it to multiplication, times 75 over 24x. I'm going to look to just start canceling. So 5 goes into 75 15 times. 6 goes into 24 4 times. So I have 15 over 4, and now take a look. I have x to the 4th and x to the 1st, so that becomes x to the 3rd, right? 4 minus 1 is 3. There we go. Next one, I have 16 x to the 4th y over 15 w to the 3rd. Now, this one again does not have a denominator, so we're going to put it over 1. Keep change flip, so we're going to change to multiplication, rewrite 2x to the 5th times y. What do we notice? 2 goes into 16 8 times. Okay, so I have 8. I have x to the 4th, x to the 5th, so 4 minus 1, or sorry, 4 minus 5 is negative 1, so that's x to the 1st on the denominator. Notice I have the y and the y, so those cancel. And, oh, I forgot to put my 15 here. I still need my 15. And then w to the 3rd is in the denominator. There's nothing to combine, so we leave that. Next one, so I have 3m plus 12, so I'm going to factor out a 3. I'm going to be left with m plus 4 over m plus 5 times, now I'm just going to flip it, so I'm going to make this m minus 2 plus m plus 4. What can we cancel? M plus 4. So what do we have left? 3 times m minus 2 times m plus 5. Next one. So you'll notice I'm starting to factor and flip at the same time, so you can do that as well. X squared minus 16, so that's going to be x plus 4, x minus 4, difference of squares. Then I have x squared y. And again, if you need to pause it, because I'm going too quickly, you can easily pause it and then go back and try it on your own. All right. Oops, actually, I'm going to flip it because I changed this to multiplication, right? So xy squared. And now I'm going to factor x squared plus 5x plus 4, so that's going to be x plus 4, x plus 1. Let's see what we have in common. We have an x plus 4 and an x plus 4. And so, now notice we have x to the 1st and x squared, so that's going to leave us an x in the denominator. We have a y squared and a y to the 1st, so that's going to be a y in the numerator. And then we also have an x minus 4, and we have an x plus 1, so this one looks a little more complicated. Okay, last two. So these are both divisions, so I'm going to keep. However, I notice x squared minus 25, so I'm going to write x plus 5x minus 5 times, now we're going to put change, flip, so x plus 5, and then x squared minus 1 is x plus 1, x minus 1. So what can we factor, or cancel, I'm sorry, and then x plus 5s. What are we left with? Oh, now notice everything canceled in the numerator, so we got to put a 1 up there. What do we have left in the denominator? X minus 5, x plus 1. Okay, last example, so keep. Now I'm going to try to factor this. Two numbers that multiply together to give us 26, combined to give us 11, negative 11. I'm thinking 13 and 2, so minus 13 and a plus 2. Change, division to multiplication, flip. X plus 7, x minus 13. What can I cancel? X minus 13. Is that it? Yes. So what do I have left? X plus 2, x plus 7, all over 7. Okay, so give the homework a try, and I will see you in class, and we'll talk about if we have any questions. All right.